Alright, in this section, what we're going to do is we're going to take a look at rational numbers, section 2.2, and rational expressions. Okay? So, we have this. A rational expression is an expression in the form of a fraction. Remember, all expressions can be placed in a rational form by placing them over 1. Think of it, you can put a 1 under anything, just like a number or an integer, making it a rational number. An algebraic rational expression involves having a variable in the denominator. So all these down here are all variable expressions. See how y is down there, 3y, 2x minus 3. Now, what are we going to do with these things, okay? One of the things we have to consider is what makes the expression have no meaning, or what value does it make the expression undefined, okay? I.e. when the denominator equals 0. That's a problem, okay? You're dividing by 0, so black holes come from, paper bursts into flames, a lot of bad things, bad omens, okay? So a lot of times you want to take a look at it. For later on, we're going to look at it and say, oh, that's where our function's not defined, and it's not going to be in our domain. But for our sake, we should be able to at least find the problem points, okay? So how do you find in the equation here, this rational expression, where does it have no meaning? Well, all you got to do is set the bottom equal to 0 and solve, okay? You don't have to worry about the top at all. You can just block it out. It's irrelevant for our problem. And just set that equal to 0. This is from the first chapter. Factor it out. X, 4, 2, minus, plus. Set each of these equal to 0. And solve. X equals 4, x equals minus 2. If you plug it into this thing right here, you'll see if we put a negative 2, let's just say, that's negative 8 over 8, and then we get 4 plus 4, which is 8, minus 8, which is 0. We get 0 over 0. That's even worse, okay? So what's going to happen is those graphs are going to create things called asymptotes, or lines that we get infinitely close to. Alrighty? So we'll talk about that in chapter 4 a little more, but we like to find those places, especially in calculus. We want to see what happens there. So, reducing the lowest terms is one of the fewest things. We're going to use this in every type of problem, because we like fractions in lowest terms. Even rational expressions should be in lowest term. To reduce a rational expression to lowest terms means that the numerator and denominator have no common factors. Okay? This usually is accomplished by factoring both the numerator and denominator and canceling out the common terms. Remember that when we cancel, what is left? A 1's left, okay? X divided by x, cancel out, is 1. 1 left there, 1 there. So things magically, like, disappear, okay? So I'm going to reduce all these rational expressions to see how we can do it. Let's take a look at this one over here. We get 2x plus 1 over the bottom, which can be factored at 2 out, and we get 2x plus 1. Okay? We then will cancel out common factors. So we'll take care of that, and I'm left with 1/2. Okay? We are not plug in any number, you're going to get 1/2. Right? Except for one number. Okay? When is this undefined? Well, to find out when it's undefined, you do 4x plus 2 equals 0. And if you do that, it's minus 2 equals 4x. And x equals negative by half divided by 4. Okay? That's a bad thing. Okay, that number plugged in gets you a bad spot. So a lot of times you're going to look out for that. This is where it's undefined. But the rest of it, that's what our thing actually reduces to. Let's take a look at the next one. 3x minus 6 can be factored out to a 3 out. X minus 2. Well, the bottom can be factored out here. I'm going to go with x 4, x and 2. Bigger one's positive and a negative. Okay? Now, if we do this right, all I got to do is cross out common factors. So, I want to cross out that one and that one. And I get 3 over x plus 4. Okay? That's the reduced term. But if I want to know where it's undefined, you would set the bottom equal to 0. Well, that's x squared plus 2x minus 8 equals 0. You ignore the top, okay? We don't have to worry about it. We only look at the bottom piece, right? Well, if you notice, we've got it factored from before. Set those equals 0, you get minus 4, and x equals 2. Those are my bad spots there. Bad, bad, bad. Okay? Take a look at this one right here. Top doesn't factor. The bottom does. x minus 1, x minus 1. Gotta get negative times the negative is positive to get two negatives. Okay, cancel out 1 over x minus 1. Alright, simple, okay? Then if you wanted to know where it's undefined, well, set the bottom equal to 0. It's x minus 1, and x minus 1 equals 0. So x equals 1 and 1 again. It's a double root, actually, as we call it, because it happens twice. Right? The last one we want to take a look at. They look almost the same. It's kind of like that. It looks like a duck, quacks like a duck. It's probably a duck, right? Well, they're almost the same. Okay? The only difference is they're off by signs. But what you can do is you can actually take the bottom one and factor out a negative 1. Don't say divide out, factor out. Well, that switches the signs. Because then it's x plus 16. Or, I'm sorry, x minus 16. Oops. Okay. If you were to redistribute, you get negative x plus 16, which is what we had. But now you can see these two are exactly the same and cancel out. And we get actually just negative 1 over 1, which is just negative 1. So you can see these things are the same. They do cancel out. They're just off by a negative sign. When is this undefined? That's an easy one. 16 minus x equals 0. When x equals 16, we got a problem. Okay? So you can see we're going to use that many, many times with these problems. Okay? We have lots more. Just to show you, we can do some of these. We'll do not all of them, but enough of them. Over here, we could factor out a 6. And then you get 2 minus x. The bottom factor is 2x plus 2. X minus 2, different squares. These, okay, this is so close to one of these. These are, it's a plus and a minus x, so we have a plus x and a minus 2. These are close. They're off by a minus sign. If we take the negative out, and we got that, negative 6 over x plus 2. Where's this undefined? What's nice is, if you factor the bottom, you just look at the bottom and set those equal to 0. X minus 2 equals 0. X equals minus 2 and x equals 2. Now be careful. People will like to find if it's undefined by plugging into this one. You got to do it before you cancel. Just be aware of that. If I have this one right here, this is 3 factored out, w minus 3. And then this is a difference of squares again. 3 plus w, 3 minus w. And what do you know? They're off by signs, okay? So that's a negative 1. Negative 3 over 3 plus w. When is this undefined? Again, we set 3 plus w equal to 0, 3 minus w equals 0, and you get w equals negative 3, and w equals 3, right? We could do this one. This is a difference of cubes, okay? This does factor. If you wanted to know what it factors to, all you got to say is, oh, that factors to the square roots in the same sign, so x minus 2. I square the first term here, that's x squared. Square that term, it's 4. Multiply these, negative 2x, and then change that plus 2x. So that does factor, and I'm not going to get into that, okay? So let's take a look at my last one here. 3y squared minus 27 over 3y squared plus 21 plus 18. Now let's see if we can factor a 3 out to start, and that's y squared minus 9 on the top. The bottom, if we factor a 3 out, we get y squared plus 7y plus 6. Right? They still factor. Don't lose the 3's unless you start canceling them out there, but we can do that, I guess. So, top factors are y plus 3, y minus 3. Well, the bottom does factor as well. Y plus 6, y plus 1. Alright? If you look, well, can't factor, can't cancel. People try and cancel the y's out. Can't do that. We're just stuck with this, actually. The only thing that canceled out was the 3. Alright? So you can see we have some of these things. The little problem here I ask is, which is it defined for every rational number? Which one, if you look, can you never solve? Well, if I look at this one, this difference of squares, x plus 4, x minus 4. Well, you can get 4 and negative 4. That makes a problem. You said this one, 3x minus 3 equals 0. Get x equals 1 there. No, this one, you get x squared, 2x squared equals 2, divided by 2, it's x squared equals 1. Square root. Square root of x squared is x, which is 1, and plus minus. Now, how about the first one? Now think about this. First of all, if you solve, it's x squared equals minus 4. You take the square root, not real. It's imaginary, we'll get to that. However, just think about it. take any number and square it. You always get a positive. Do two positives ever give you 0 or negative? Okay, it doesn't. So that was going to finish up off there. Okay, our last question is for what real values is x minus 5 over x squared minus 5 undefined. A lot of people try and factor and cancel here. All I got to do is x squared minus 5 equals 0. X squared add 5 equals 5. And then take the square root. X equals plus minus the square root of 5. Those are real numbers. Because they're irrational, it doesn't make a difference. Okay? So, as you can see, we're going to finish there. Just recapping. Undefined. Denominator equals 0. And then to simplify, factor and cancel. Alright? So, have a good day, and I'll talk to you later.